Hi! In this video I'm going to show you two examples of optimization in terms of maximizing profit. The key thing that's going to be difficult here is the formation of the profit function. As soon as we have that profit function in hand, then it's just going to be a question of finding the absolute maximum using calculus. Okay, so let's get started with this first example. In example number 1, the revenue function has been given to you and the cost function has been given to you, and both of these are going to be in dollars, where X is in number of items. And the question is going to be, find the maximum possible profit. Okay, so we'll go through this one first, and then I'm going to challenge you to approach a more complicated problem where here I haven't even given you the C of X and R of X. I've just told you that the average cost in dollars per item is given as this function, and then the information that the product sells for $1,600 an item. An added limitation is that my production is limited to 450 items maximum. So these are all a little bit more difficult issues. Same question though, find the maximum possible profit. You can try both of these right now if you'd like to on your own and kind of see where your skills are. Okay, so let's get started with this one. What do you think the first step is? Form the profit function. That's right, we can't maximize a function if we don't even have the function. Or can we? Actually, if you remember from the first video, you'll remember that maximizing profit, since profit is equal to R minus C, and what we're going to do is we're going to set pre-prime equal to 0, it can also be found by saying that R prime minus C prime is equal to 0, or searching for R prime is equal to C prime. Okay, so there actually are two different ways to find this. We could consider the place where the marginal revenue equals the marginal cost, and that's the same thing as considering the place where the marginal profit is equal to 0. Okay, so either way you want to do it, but I would like to have the profit function in hand because the question is find the maximum possible profit. So not only will I have to find the X value at which the maximum possible profit occurs, but I'll also have to plug it back into profit in order to get the Y value, which is the dollars that are the max profit. So I might as well go ahead and form that profit function, and that's going to be R of X minus C of X, and be really careful here. When you're subtracting off C of X, you must include an outer parentheses there so that the minus sign will factor through each and every one of the terms. Okay, so the first thing that I'm going to do in this process is factor this through, combine any like terms, which I don't see any, so that should be easy. And I'm also going to reorder this polynomial from highest order downward into lowest order, because that's the preferred way to express a polynomial. From the cubic to the quadratic to the linear, and finally, don't forget to factor through the minus sign, the constant term. Beautiful. Did I do it right? I hope you guys are checking. I know you are. And I appreciate your comments. So anyway, here's the profit function right here, and now we just have to do the calculus, which is to say, take the derivative, set that equal to 0. Might just want to go ahead and do this one all by yourself if you want. And remember, technically, when we're locating relative extrema, we should also try to set it equal to does not exist. But in the case of polynomials, which is the most common functional form that you'll encounter in business, in the case of polynomials, you don't have to consider the does not exist part. Okay, so we just have to simply solve this equal to 0, simply or difficultly, because it looks like I have to use a quadratic formula. Uh-oh. Now I don't really like doing anything that's any kind of complicated. So if you can get out of using the quadratic formula and factor it, that would be best for me. It looks like all of these coefficients here are divisible by 3, and likewise divisible by minus 3. So I'm going to go ahead and divide everything out by minus 3. You see, I'm going to divide both sides of the equation here by minus 3. That's because it's more fun for me to try to factor if I just have a 1 as the coefficient of my quadratic term. Okay, so when I divide that out by minus 3, you're going to see that you're going to end up with the equation that x squared minus 40x minus 1200 is equal to 0. Now technically this is not p prime anymore. This is p prime divided by minus 3. So that's why I have not written p prime anymore. But it's the same equation because set equal to 0, so it's going to have the same roots, the same solutions as the original p prime equals 0. Okay? Is it a good idea that I did this? Do you guys see now that it might factor? Let's see, 1200. That's like 60 times 20, right? And 60 and 20 have a difference of 40. So it looks like I'm in luck because if I say x plus 20 times x minus 60, it looks like those two terms would add together to make minus 40 and multiply together to make minus 1200. And so it factors beautifully. Hooray! So I could get out of using the quadratic formula. But if you don't like factoring, go ahead and use it every time because the quadratic formula works every time, barring any typos. That's kind of the caveat there. In my conclusion, I have that my critical points are x equals minus 20 and x equals positive 60. But remember, I'm inside of a word problem right now, an application. How many of these critical points are really appropriate or applicable to x being a number of items? Only this one, right? So x equals 60 is my real only possible critical point that I should consider. And then once I get the x equals 60, then what I have to do is I have to make the p prime sign number line. Okay, so there's the p right there. I'm going to erase the scratch work here. And here's the original p prime, which was minus 3x squared plus 120x plus 3600. Now when I make the p prime sign number line, remember I want to know what's the sign of p prime. Okay, so that means I'm going to take off x equals 60 because that's my critical point that I found. And when I use test points, I need to plug each one of my test points into p prime, the original p prime. Not the p prime that I divided by negative 3. You know why? Because I divided that by negative 3, so technically that would have the opposite sign of what the sign I'm actually looking for has. Okay? So keep in mind that even if you divide it out by something because you were solving that this equals to 0, when you go to the next step, which is the formation of the sign number line, you must plug your test points into the very original statement of the derivative. Okay? So no matter what you put your test point, like for example over here, I could have tested x equals 0 and come out with positive 3600. So that means it's always plus. And if I test point over here, x equals like 150 zillion, you can see that this negative quadratic term is going to take over. So those are all going to be negatively signed. And so the first derivative test allows me to conclude that my function was rising, hit a peak, and then started decreasing again. And so that means x equals 60 is going to be my relative max. Alright, relative max, but is it my absolute max? The best way to answer that question is going to be to graph the function that you're interested in optimizing. Okay, so here's a statement of the profit function right there. And so what I would want to do next, or possibly even the first thing that you do in the problem, is going to be to take a nice picture of what function you're interested in optimizing. And a graph of this function kind of looks like this, where it looks like the number 20 was over here and 100 was over here, just to kind of give you the scale of things. And it looks like the profit was pretty big, so you're going to want to make your Y max probably in the hundreds of thousands. Try using your Y max as, I don't know, 200,000. And try using your X max as at least 100 so that you can see a nice looking picture of the profit. Okay? And then that confirms for you that x equals 60 is the relative max. Not only that, it's the absolute max because you can see it's the highest thing that this will ever attain. Okay, so right here we have the absolute max at x equals 60. But if you remember, the original question was, find the maximum possible profit. And profit is in units of dollars and it's a Y value. So the final step to answer the question that I was posed is going to be to take x equals 60, plug it into the original profit function, and then you're going to get as an xy point 60, $144,000. Okay, so then my conclusion right there, and that's from plugging it into the profit function. And so my conclusion is that the absolute max possible profit, remember to answer whatever the question is that they gave you, is going to be the dollar amount, the Y amount, of $144,000, and that will occur when I'm making and selling 60 of these items. These must be some real fancy items that I'm selling in this problem. Alright, so hopefully that went well for you, because now we're going to rev it up a little bit to where we've given you kind of less straightforward information than that. Remember, the hardest part here is going to be the formation of the actual profit function. P of x is equal to R of x minus C of x. But look at this. I haven't even been given R of x. I haven't even been given C of x. So that's kind of tricky. Okay? Can you get R of x from this? Can you tell me what the function R of x is going to be from some sort of information in this question here? Let's see. That talks about cost, so that's not it. This is the selling. Okay, this is where I'm making my money, is I'm selling them for $1,600 a pop. So what does that mean? R of x equals 1,600x. Exactly. That's what comes from the fact that the product sells for $1,600 per item, and so R of x is going to be the price times the number of items. Nice. So I got my R of x. Now, if only I could get my C of x, then we could really get going and do all the analysis that I did on the first one. Right? Okay, C of x. Well, I've got C bar of x. And do you remember how C bar, the average cost per item, is related to C of x, the total cost? Let's see. Well, the average cost, as I've shown you before in some other examples, is taking the total cost and dividing it by x, right? And that's why it comes out in dollars per item. You see, the average cost describes the cost of just one single item, so that's dollars per item. And that's because I took total cost in dollars and divided it by items. Dollars per item is the C bar. Now, usually I've given you the C and I ask you for the C bar, but you can always do that backwards, which is to say if I multiply both sides of that equation by x, I get that C bar of x multiplied by x is equal to C of x. Oh, so I can't find C of x. I just have to take C bar that's been given to me and multiply the whole thing by x. There's an analogy going on here between total cost and total revenue. You see, total revenue is equal to the price per item times the number of items. Total cost is equal to the cost per item times the number of items. Okay, so there's an analogy there, and we can just take that C bar and multiply it by x. Okay, so we got that one right there, and then we can just say because of this, that if my average cost is that equation, then my total cost is each one of those terms individually multiplied by x. What's going to be the units on C? Dollars, right? Because C bar was dollars per item, multiplied that by number of items, so this is going to be in dollars, and likewise this is going to be in dollars because it was $1,600 per item times the number of items. And now we can do this, but wait, there's one more sentence that I have not erased yet, so I should probably turn this sentence into math too, so I don't lose that part of the problem. Production is limited to 450 items max. That's the most that I can make in my factory. So what does that mean mathematically? What is that speaking to? The domain of the function, right, because it says, like, what's the absolute highest value of x that I can put in. So this last sentence translates mathematically into a domain where x must, of course, be not a negative number, so 0 is the smallest it could be, but the max it can be in this case is 450. I didn't have any maximum in my last example, but you can see that when I plotted my profit, it was obvious that I shouldn't make too many of these things because that's going to end up as a negative profit anyway, so I didn't really have to consider having a high end on my domain. Okay, this question has been given to me, so I definitely want to address that. Alright, so now let's go on to find the maximum possible profit. We have something set up for us. And the next thing we're going to do is P of X is going to be R minus C. So that's going to be 1600X minus all of this in parentheses plus X squared. Okay, and so what I can do is I can actually form that, just like I did in the last example. I formed the P. Here I would want to combine the like terms of 1600X minus 200X. Take the derivative, set it equal to 0. But since we're here and we've already done that over there, I might as well show you the alternative way, which was the alternative route was set the marginal revenue equal to the marginal cost. Remember how we talked about that? That's the same thing as setting the marginal profit equal to 0, because marginal profit is MR minus MC. Okay, so I could go this route like I did in the last one, and I invite you to do that on your own if you like. But I will take the alternative route so you can see both ways to go. Okay? Let's see how much you remember here. What's my marginal revenue going to be? $1,600, right. And that was the same thing when I said I was selling them for $1,600 each. That's the information of marginal revenue. Here, it's a linear function, 1600x. So my marginal revenue is 1,600, right. What's my marginal cost? Well, that's not a linear function, so I can't get that as the slope of the linear function. Looks like I'm going to have to take the derivative in order to derive the expression for marginal cost. This constant term goes to 0, this term goes to 200, and the other term goes to 2x. And if you're playing along with the other route, where you've simplified the like terms here and taken the derivative of that and set it equal to 0, you should arrive in the same situation that I arrive in, which is that you end up having to solve this linear equation, 1400 is equal to 2x. Did you get there either way? I hope so. Great. Okay, so then this sounds actually easier than the last one because it's not even a quadratic. We don't have to factor it. We just have to divide by 2 and come to the conclusion that x is equal to 700. Okay? Once again, be aware that the strategies that we're using might be finding minimums instead of maximums. It could even be an HPI. So we always want to make sure that we do this side by side with a nice pretty picture so that we can confirm that x equals 700 is a max. Alright, so let's see, we got this profit function right here, so we can take a nice picture of it. X, looks like I got something like this. And remember, you're probably going to have to set your axes appropriately. Like usually when you're using your graphing calculator, the standard box is -10 to -10 in both directions. Here, the x should be maybe 0 to like 1,000. And then the y's, it looks like the profits, oh geez, look at that. If I don't make anything, my profit is negative 37,000. So that tells me that my profit is at least in the tens, if not the hundreds of thousands of dollars. And so you're going to want to set your y-axis accordingly to that. Hopefully you arrive at this pretty picture, which happens to be a down-facing parabola, because you can see the functional form of this is going to have a negative quadratic term, and it's going to be a down-facing parabola. And so that guarantees for me that the vertex is going to be the absolute max right here, is going to be the absolute max. Yay, I found it. X equals 700 is my absolute max. Let's go, guys. Let's make 700 of those items. Right? No? Oh, no. Our factory's not set up for that. Remember when it said the production was limited to 450 items at max? Oh, man. Well, at least I know that if I could make 700 items, I would be attaining my absolute max. However, there's a domain restriction, and you always have to pay attention. If they've given you information like that, you always have to watch out for that, because x equals 450 turns out is going to be the absolute max for my abilities, okay? Now, if I did have a factory that could make 700 of them, sure enough, I would make even more profit. But I don't have that. That's not possible. It's outside of my domain. You see? X equals 700 outside of my domain. What is the answer to the absolute max? In this case, it's one of the endpoints. because 0, that's a bad idea. I'm going to lose $37,000 if I don't do anything. And then my profit just keeps going up, 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 until I hit my absolute max at x equals 450, which is the maximum capabilities of my production setup. Okay, did I answer the question? What was the question? What is the maximum possible profit? Right, right. So it's not just the maximum possible profit occurring at 450, but like how much money am I actually going to make there? So you have to take the number 450 and plug it back into the profit equation right there, and then you should get the number 390,500. Okay, so the maximum possible profit in this example is $390,500. Okay.